Hello everyone and welcome back to the channel, and this is the seventh part for VPC. And if you haven't watched the previous parts, then I would request you to please watch them because we already have a lot of videos for VPC already. And in today's session of VPC we will be talking about NAT, and we will get the answers today to the question of how can we connect our instances at private subnet to the internet. And I'll give you a brief idea of how this can be achieved. So without wasting any more time, let's begin. And in today's episode, we will be talking about what is NAT and what are NAT gateways and NAT instances, and what are the difference between NAT gateways and NAT instances. And if possible, we'll also have a small demo on each of them. And the timelines are already given in the description below. So if you wish to switch to a specific topic, you can do that as well. So when we think of public IP addresses and the time it came into introduction, everyone believed that it would be sufficient because of the amount of public IPs that we had at our disposal. With the 2 to the power of 32 IP address range, which is about 4,294,967,296 public IPs, among which we have 588,514,304 reserved IPs. That's a mouthful. Here, no one expected it to become scarce in just a few years, and it became very hard to manage the World Wide Web with the decreasing number of free public IPs. Let's take a moment and imagine a scenario where people sitting at home had a lot of devices that needed internet connectivity, and they were using the IPs from the pool of the public IPs to connect to the internet. May it be your laptop or phone or smart speakers, everyone was just using a public IP address. But with the growing demand for devices and the way people got addicted to media devices around the world, billions were now online, and it gradually kept on decreasing the count of the IPv4 public IPs. And it was at that stage we felt the need for private IPs. And now, along with the public IPs, we had a range of private IPv4 addresses that could be used to attach to the devices. And if private IP was a solution for the dying public IP address pool, let's see what happens when we attach private IPs to our devices. Here we have all our devices in our local network with our private IP, and we assumed everything would work fine. Well, that didn't go as expected, isn't it? We believed that private IPs are the solution to our internet connection, but the issue was that only the public-facing IP addresses have the capability to connect to the internet. And that's a very concerning thing. So let's change something in the configuration. Now, let's introduce a NAT device. That is the Network Address Translation Device, or what you may also know as your router. And let's see the magic unroll. And yes, now you're able to watch movies and listen to your songs on your laptop and iPads. But what exactly happened when we attached a NAT device? And how you're able to connect to the public internet using the router or the NAT device? So if I tell you that it's a type of device that allows multiple devices to access the internet through a single public address, you might ask me, like, how is it even possible? Think of NAT, or Network Address Translation, to be a process in which we translate one or more local private IPs into global public IP addresses so that we can get connected to the World Wide Web. Don't worry about the working principles of this. We will talk about this in short in just a moment. For now, you have to remember one thing. The device that you are using in your home might be connected to the Wi-Fi router or an Ethernet cable, but they are within the local network, which will have their own private IPs. That is the same reason why if you take that local IP of your laptop right now and try to access it from a cafe or office, you won't be able to access it because it's not a part of your public IP space. That is the reason why you talk to your ISP or the internet service provider and get an internet connection and attach that optical fiber cable that you get to your router, and you connect your devices to the Wi-Fi router in order to get the internet access. And when you connect your devices to the router or NAT device, it'll keep the track of the MAC addresses of the devices and its IP addresses, and all the requests that is being made or requested. And how does the router do that? Yes, the answer is NAT. And I'm not saying that's the only thing that goes around, and there are other things like routing as well, but we are talking about NAT, so let's stick to that. I really wanted to skip this part, but I felt even if this may not be important for the exam, but it is something that is really important for everyone to understand the concept of how the NAT actually works. So let's not skip this. We will learn this as well. And I would request you one thing, that throughout this explanation, keep this in mind. NAT translates local private IP into a global public IP and vice versa. Okay, so let's see what happens in the explanation. So we are at our home using our desktop computer and we want to access the internet. Our local IP block is 192.168.0.1/28. That is what is called our inside local address, which is not provided to us by the service provider, but instead it's our very own local IP, which can be accessed within the local internet. That is the private IP. Now we send the request to the NAT device. There can also be multiple devices sending the request to the NAT device. So we also have inside global address, which acts as an IP representative for one or more local IP addresses. That is called IP masquerading, which can be an IP from the block 47.12.22.3/24. With that public IP, you are able to connect to the public internet. But having said that, it's a request and response architecture, isn't it? So when you send a request to the outside world or to the World Wide Web, you will also get a response, isn't it? Or you will expect a response, isn't it? And for that, we need to translate the public IP to a local IP address so that we can get the response back to the device which requested it. And there comes our response, and it's back to our public IP, that is the outside global address, that is the before translation IP address as seen from the outside world. And now that we have the response back, we can translate the global IP again to the local IP addresses which is available or which is visible to the local network. And the response is sent back to the device, and that is what is called our outside local. So the process is to translate one or more local IP addresses to global IP and vice versa, so that we can communicate with the public internet. So here we make the request, and this is the IP that gets translated using the network address translator, and which gets connected to the internet and gets the response back to us with the same or a different global IP, and which gets again translated and gets sent back to the device which requested it. So that is why I said it's a process of translating one or more local IP addresses to global IP and vice versa, so that we can communicate with the public internet. But how does the NAT know which IP the request has come from and to whom the response is meant to be sent? So when we look through the eyes of the NAT, all our devices have a local IP which is our source IP. And we have a web service to which our devices are willing to talk to, which is our destination IP. So this is how the NAT table looks like. All the source IP have a source port which is mapped to a translated public IP which will be used for communication over the NAT device. If you see here, we have the different source IPs but the same source translated IP. Here, the source IP is different but the source IP translated is same. And using the port and the IP mapping, the NAT actually does a reverse address translation and sends the appropriate response to the one who has requested it. I hope this was clear. Let's move on to the AWS NAT and let's understand how we can provide internet access to our instances at the private subnet. So just like we discussed before, the NAT device actually helps us to enable instances in the private subnet to connect to the internet. We all know that the instances which are in the private subnet have the main route table pointing to the VPC subnet CIDR to the local VPC as the target. And that is why it doesn't have internet access, and the people outside also cannot access these instances. So along with that, it actually helps us during software updates, or if we want to use it for accessing other AWS services. And also it helps us to forward traffic from the instances in the private subnet to the internet or other AWS services, and also sends the response back to the instances. So for this, AWS offers two kinds of NAT devices. So the first one is NAT gateway and the other one is the NAT instance. And AWS recommends that we make use of the NAT gateways as they provide better availability and bandwidth over NAT instances. Don't worry, we will get to know about both of them. So now let's start off with NAT gateway. So NAT gateway service is a fully managed service from AWS that helps us enable instances in a private subnet to connect to internet and other AWS services. Yes, you heard it right. It's a service, so NAT gateway service, and it's completely managed by AWS. So there are way less things to be worried about when you use NAT gateway service. So NAT gateway actually supports 5 Gbps of bandwidth and automatically scales up to 45 Gbps. And as this is a service, you will be charged for the usage as well. And you are charged for creating and using a NAT gateway in your account. And you will be charged hourly for your usage and data processing. That is, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. And data processing charges apply for each gigabyte processed through the NAT gateway. So if you see here, for AP South 1 region, the charges for NAT gateway per hour is $0.056, and for per GB data processed, it's also the same, that is $0.056. And NAT gateways are not supported for IPv6 traffic. We need to use outbound only egress internet gateway for that. So now let's see how we can create a NAT gateway. So there are very simple steps to create your NAT gateway. So the step 1 is you must specify the public subnet in which the NAT gateway should reside. Yes, the NAT gateway should reside in your public subnet, which means it is associated with the internet gateway. So I think I gave you the clue right there. And step 2 is basically specify an elastic IP address to associate with the NAT gateway. That is the IP that will be used to create IP masquerading. So that's really important. And step 3, update the route table associated with one or more of your private subnets to point internet bound traffic to the NAT gateway. So if you have more than one or more private subnets, you can add them to the route table for them to get associated with the NAT gateway, but it is advised to have one or more in each subnet. And you can have more than one NAT gateway per availability zone, and the quota is a maximum of 5 per availability zone. A NAT gateway in the pending, active or deleting state counts against your quota. So even if they are in these 3 states, it still counts as a +1 for your quota limit. And here as well, we need to consider the availability zone independent architecture. And for that, AWS tells us to create a NAT gateway in each availability zone and configure the routing to ensure that resources use the NAT gateway in the same availability zone. Else they might have a single point of failure. Now let's see the visualization here. So here we have our availability zone, which has a private subnet, which has our database instances that needs the internet access. So the main route table for the private subnet sends the request to the NAT gateway, and the NAT sends it to the internet gateway using the elastic IP, which acts as a source IP. So I agree it's not a magic one-touch connection, but for your instances at private subnet to access the internet, they have to talk to the NAT gateway which resides in the public subnet. So this is the public subnet where your NAT gateway should reside. And using the internet gateway here, we actually connect to the internet. So if your instances at private subnet want to access the internet, they have to talk to the NAT gateway, which resides in the public subnet, using the internet gateway, which in turn gets connected to the internet. But all that happens with the help of the route tables, as you can see. So all the instances here making a public IP address request actually goes through the NAT gateway ID, and then it forwards it to the internet gateway, as you can see here. So I hope you got the idea here that if your instances that are in the private subnet want to have internet connection, they have to go through the NAT gateway which resides in the public subnet. So public subnet means your subnet will have access to the internet gateway through which you will be able to access the internet. So now let's talk about some of the important rules and limitations for creating a NAT gateway. So the magic number here, NAT gateways actually support 5 Gbps of bandwidth and automatically scales up to 45 Gbps. And you can associate exactly one elastic IP address with the NAT gateway. So remember this very carefully. And you cannot disassociate an elastic IP address from a NAT gateway after it is created, because if you wish to do that, you must first create a new NAT gateway with the required address and update your route tables and then delete the existing NAT gateway. And the NAT gateway actually supports the following protocols, that is TCP, UDP, ICMP. And you cannot associate a security group with a NAT gateway, that is because it is important to use it for your instances at the private subnet. And you can use a network ACL to control the traffic to and from the subnet in which the NAT gateway is located, because it is the subnet level. And NAT gateway cannot be accessed by a classic link connection that is associated with your VPC. So remember this very carefully while designing applications. And the next point also is very important, because you cannot route traffic to a NAT gateway through a VPC peering connection, a site-to-site VPN connection, or AWS Direct Connect. And a NAT gateway can support up to 55,000 simultaneous connections to each unique destination. I think that's sufficient for a normal usage. And let's suppose you're migrating from the NAT instances to the NAT gateway. You can easily do that with these simple steps. So the step 1 is to create a NAT gateway in the same subnet as your NAT instance. And the step 2 is also very easy, because you have to replace the existing route in your route table that points to the NAT instance now with the NAT gateway that you have recently created. And the step 3 is disassociate the elastic IP address from your NAT instance and then associate it with your NAT gateway when you create the gateway. So now let's talk about the less efficient one, the NAT instance. Yes, it's an instance, and it's an EC2 instance that acts as a NAT device. Okay, and just like any EC2 instance, you have to create your own NAT instance. And I hope you understand the issues that come along with that. So that is the same reason why AWS tells us to go with the NAT gateways, because it is a fully managed service. But nevertheless, we have to discuss this. So NAT, or network address translation instance, which like your NAT gateway resides in your public subnet and helps us to enable instances in the private subnet to initiate outbound IPv4 traffic to the internet or other AWS services. So this as well does not have support for IPv6 traffic, and for that you have to go for the egress only gateway. And NAT instance quota depends on your instance quota for that region, because it's an EC2 instance, so that will be applicable as per the charges that are incurred in that region. So now let's see how we can create a NAT instance. So here we can use the Amazon Linux AMIs that are already configured to run as a NAT instance. So that's a big relief. You don't have to take that headache of creating one for yourself. And you can search that in the list of AMIs that we have, which the extension or the naming convention, that is like AMZN AMI VPC NAT. And you can create your instance with that AMI with the instance family and the storage that you need. And you have to attach an elastic IP to it. And the good thing is that you can assign elastic IPs to your instance after it has launched as well, if you're not going to go with the same public IP that was added as a part of the launch process while creating the EC2 instance. And there are a few config changes that happen when we launch NAT instance AMI. So here the IPv4 forwarding is enabled and ICMP redirects are disabled in the NAT setting configuration file. And as a part of the boot launch configuration, the script configure-pad.sh runs at startup and configures IP table IPs. And let's see the explanation here for the visualization that we have. So here as well, we have our AZ, which has the private subnet, which has our database instances that needs internet access. So the main route table for the private subnet sends the request to the NAT instance, and the NAT actually sends it back to the internet gateways using the elastic IP or the public IP that we have, which acts as a source IP. Similar to what we saw in the NAT gateways, here as well, the main route table redirects traffic to the NAT instances in the main route table, and the custom route table tells it to be forwarded from the NAT instance to the internet gateway. And that is how the instance at private subnet gets internet access. And the only difference that you see here is basically between the NAT gateways and the NAT instances. And the very important thing is to ensure that you have the main route table configured for all the public routed internet connectivity to the NAT instances or the NAT gateways in the NAT gateways section. And the NAT gateway or the NAT instance should point everything to the internet gateway, because this is the public subnet. So I hope you understood this very carefully. And if you haven't, then I want you to watch this again and again so that you have this concept cleared, because this is very important. And these topics may be of less importance or less percentage in the exam, but they cover the very important aspects of VPC. So please read more about them in the documentation as well. So that's all for today's session. I hope you enjoyed this, and make sure you check out the other parts of the VPC if you haven't. All the links are given in the description below, and if you do support me, the links to Instamojo, PayPal and Patreon are right there in the description as well. So until next time, it's Pytholic signing off.